We have this coordinate system X, Y, Z, all right? And we are trying to locate the centroid of the wire. Right? Want to know if this is the wire? You know, the wire is like this, and then it goes around like this in XY plane. It continues along y-axis, and it goes down in YZ plane, parallel to x. And this is the whole wire. I want to find out where is its centroid. Now look at those simpler shapes. We have semicircle, we have quarter circular arc, and we have arc of circle. In this case, we do see a semicircle there. So here's what we do. We have to break this into simpler shapes, and then using the information we have from the table and the fact that it's a composite body, we should be able to find its centroid. Right? So we're going to divide it into three parts. This part, this semicircle, right? This is just semicircular arc, semicircular. And then this part, which is basically just a straight wire, and then this part. So this is part 3. I'll go like this. This I'll call part segment 2. It's better to call it segment 1. So we have a semicircle, one straight line along y-axis, another straight line parallel to z-axis in negative direction. All right. Now here is what we do. Right, just the general procedure that makes your life easier and is less chance of making a mistake. We create this table, call this segment. We say, well, how many segments do we have? We have segment 1, segment 2, and segment 3. I probably should extend this because we need more. Now for each segment, remember, here's what I'm trying to calculate. Let me put them here, put it here. I want to calculate XC, YC, and ZC. What is XC? XC is summation of X I's, Li's over summation of I's or Li's or length. This is YI's, Li over summation of Li. And Z is summation of Z bar I Li divided by summation of L, right? Total length. So I'm going to make this table like this and then like this. The components I need to find what is the X bar for each, what is the Y bar for each segment, what is the Z bar for each segment, and then calculate the summations, multiplications and summations to get the numerator and then get the denominator. Here's how I do it, how they usually do it. So we say this is L, and let's say it's in millimeters since everything is in millimeters. You have X bar, right, in millimeters. We have Y bar. We have Z bar. Knowing these three, you can find X bar L for each segment. We can find Y bar L for each segment. And we can find Z bar L for each segment. We continue these lines. So let's go ahead and figure that out. All right. Segment 1, semicircular. You know what? I'm going to start with 2 and 3 because they're easier. Then we'll come to 1. Let's start with segment 2. Right? The length of segment 2, what is that? What is the length for segment 2? This is segment 2.
40 millimeters.
It is 40 millimeters, exactly. Thank you. So this is length for segment 40 millimeters. Where is its X bar? Where is its center? So it's a uniform wire, which means its center is exactly in the middle here. What is the X bar for this segment? What is the coordinate of the center of this wire? What is the X coordinate of the center of this wire? In this XYZ plane coordinate system?
Would it be 0?
Would be 0, exactly. Thank you. That's 0. Y bar. What is the Y bar for this segment, segment 2? What is the Y component of the centroid of this wire segment? It's a straight wire. So if you look at Y-axis here, this is Y-axis. So this red spot here is located at, since it's in the middle, is located at 20 millimeters from the origin. So Y bar would be 20 millimeters. And Z bar is also 0. This line is along Y-axis, so the coordinate of center of centroid for a Y coordinate of the centroid for this Y, this part of the wire segment 2 is 0. X bar L for this is basically 40 times 0 becomes 0, right? Y bar L is 40 times 20 becomes 800. And Z bar L is also 0. This is for segment 2. Let's do it for segment 3. Segment 3 is the orange. Segment are represented by orange here. And since it's a straight wire, right, straight line, the center of this wire is exactly here. Right? It's the center of this. Now looking at the center, well, start with length. The length is 20 millimeters, right? Now looking at that center, red spot on segment 3, what is the X coordinate of the center of the centroid of segment 3?
Zero.
It is 0. Yes, thank you. What is the Y coordinate of the centroid of segment 3? Where that red spot is located along Y-axis?
40.
It is 40. Only Tom is following. So 40. And what is Z? Z coordinate. I'm looking at this point, guys, right? Right here, the center, the centroid of segment 3, and I'm trying to find the coordinates of that centroid in this general coordinate frame X, Y, Z. Since it's down below XY plane along Z, so its Z coordinate would be minus 10. Right. Now for this segment, X bar L gives you 0, since X bar is 0. Y bar L gives you, it's 40 times 20, gives you 800. And Z bar L is minus 10 times 20, gives you minus 200. It's for segment 1, segment 2, and segment 3. I will see how this table is going to help us to calculate those 3 fractions. Now, let's go to segment 1, semicircular segment. We have to find its length. We have to find where its X bar is. We have to find where its Y bar is. Its length, if you go to table, we are told that, let me clean up this table. We are told that semicircular, clean up everything. semicircular arc, which is this one, its length is pi r. Right? That's what we do. Its length is pi times r, the radius, which is 60 millimeters, so it becomes 60 pi. 60 pi. If you do the calculation, I think you'll get 188.5 millimeters. Do not, by the way, do not convert when you're given dimensions in millimeters and you're calculating centroids. Do not convert it into meter. Do everything in the same unit you're given, because if you convert then things, you're going to cut off the, you lose accuracy. Let's put it this way. So keeping the same unit. And if I want to be more accurate, the unit for this is millimeter, the unit for this is millimeter, this is millimeter, this is length multiplied by length, so it's millimeter squared. It should be millimeter. I say millimeter, I write meter. Millimeter, this is millimeter, millimeters, millimeters squared, this is millimeters squared. This is also millimeters squared, right? Because it's length multiplied by length. What is X bar for this semicircular segment? Let's look. If you go to table, this is X bar, right? Wherever if you look at the table, this is where the centroid is in this table, in this for semicircular. So we're talking probably, we're looking at something around here. I see. So this length would be your X bar, whatever that length is. Along X axis, wherever it is located, it's going to be X bar. Remember, we're looking at this coordinate system. Now, how do we find that X bar? If we go back to the table tells me that C centroid for a semicircular arc is located exactly in the middle in terms of, if you look at the radius, if you look at the diameter like this, and this is the radius, this is exactly in the middle, right? In terms of length in this direction, it's basically just R from one end to the center. So this X bar is just the radius. It's 60 millimeters. Did you guys follow what I did there? So look at this. If you look at, don't get confused. If you look at this table, it says for semicircular arc, Y bar is, X bar is 0, right? But you don't put X bar 0 here. I put 60. Why? Because here the coordinate is placed here, exactly in the middle. It's important to know how to use the table, right? The coordinate is exactly in the middle. And that's why X coordinate, or wherever this is located on the along the horizontal axis, is 0. That's why we got 0. But 0 on this coordinate, which is here, is 60 millimeters in the coordinate system we have for this composite body. So very careful. Do not just plug in X bar from there to this. X bar tells you where this position point is centroid. You have to find out the coordinate of this point in the coordinate system of your composite body. It's very important. All right. Y bar. So Y bar is, well, this is Y axis, right? We have, clean that up. Put this as segment 3. This is our Y axis here. Right? This one is our Y axis. So the coordinate of this point C in Y is basically negative of whatever this height is. What is this height? If I go to my table, I know that this height is this. It's Y bar. Again, pay attention. Don't just plug in this Y bar there. The reason we got 2 over pi is because the location of this centroid for semicircular arc is at point C, and that point is along the y-axis in the negative direction. Since the origin is here, this length, whatever it is, this y bar, I'm not going to put y bar, whatever this length is, right? This would be minus y in y direction, y bar. So that becomes minus 2r over pi, 260 over pi. Right? Z bar, this is in xy plane, so z bar is 0. Right? The point C for this is located at 0 for semicircular arc. Now we do the other 3 columns. X bar L, X bar is 0, 60, L is 188.5. So you have to do that calculation. You'll get 11310 millimeters squared. Y bar L, Y bar is minus 2 times 60, but say minus 120 over pi times 60 pi. So 60 pi cancels out by pi. It becomes minus 7200. And Z is 0, so Z bar L also becomes 0. I'm going to pause here. You understood how did we use the table to find the semicircular arc center? Right? If you didn't, tell me. The table is there, but we do not plug in X bar and Y bar just blindly. You have to look at the coordinate system for the composite body and find the coordinates of the centroid for that segment in the coordinate system for the composite body. All right. Now, see what we want to find out. We want to find out XC, YC, and ZC, right? XC is sum of X bars, sum of the multiplication of X and L's, which is here. So if I can find it from here. If I sum these up, this is nothing but summation of XI, LIs, which basically gives you 13, 11, 1, 1, 3, 10. Right? So X bar is XI, LI over summation of LI. Summation of LI is just summing up all the length values. So that's actually here. It's 20 plus 40 plus 60 pi. So it becomes, let me see if I can do a better job of fit it here. 248.5. Right? So this fraction now is 11310 divided by 248.5. If you do that, you'll get XC as, if I did not make any mistake, 45.5 millimeters. Right? YC. To calculate YC, we have to, here's YC. Is summation of YIs, LIs over summation of LIs. Well, Y bar, these are bars. Y bar times L for each segment is basically this column. So if I sum these up, this is going to give me, this is bar, YI bar LI, which basically would be 800 plus 800 minus 7200. That'll give you minus 5600. So this becomes minus 5600 divided by total length 248.5, which gives you YC as minus 22.5 millimeters. ZC. summation of zi's, li's over total length, right? Summing of all the lengths. We already have this one, 248.5, and that is basically summing up the multiplication of all z bars and lengths is L bar, L. This actually is just minus 200, but let me write it right here. VI Li gives you minus 200. So that would be minus 200. ZC would be minus 0.805 millimeters. So, end of the day, what we get is this is telling me that, clean this up, segment 2 and this is segment 1, so you have it. This is telling me that the center of the centroid for this composite wire is located at x 445.5, y of minus 22, and z of minus 0.05. So it's 0.805. So it's somewhere maybe there. You can think of it as let me see, y is, well, maybe it should be more towards y because y is minus. So it's somewhere there. Track up. So this is your, I'm not sure if I draw it to scale, but this is the coordinate. This is xc, yc, zc.